Dr. D. Parvatalu is a PhD in electroanalytical chemistry from Mumbai University. He is working as a domain expert in ONGC Energy Center, and in that capacity, he has been responsible for commissioning and supervising research and development projects in many research institutes, including ICT. Earlier, he worked as a project manager of the hydrogen project team before superannuating from ONGC in 2016. Dr. Parvatalu has 25 years of experience in various quality control activities in upstream oil and gas production operations of ONGC and in onshore and offshore oil fields and regional labs. He has rich experience in chemical control for oil flow improvement, corrosion and spill prevention, water treatment systems, standard test methods, specification developments, etc. He led an international team to develop the international standard test method for screening oil field corrosion inhibitors. Dr. Parvatalu has many papers and publications to his credit and is a member of several distinguished professional institutions. May I request Dr. Parvatalu, sir, to deliver his lecture on oil and gas exploration and production, key challenges and opportunities.
Should we start?
Yes, please start.
Thank you very much for giving me an opportunity, especially Professor Ghosh and Ria for the introduction. We know that oil and gas reserves are not everlasting, so they are called as non-renewable. We may be there for another 2 to 3 decades, and then there is a lot of thrust on renewable energy and all. But however, you had to continue this oil and gas exploration and the business for day-to-day energy needs like power needs, transportation needs, and all for another 2 to 3 decades. In this lecture, just I would like to talk about oil and gas exploration and production and key challenges and what are the opportunities in this. This entire oil gas business is represented in terms of 3 streams. One is upstream, slowly dealing with exploration, field development, production operations. It doesn't do anything about refining and all. Next, midstream, this GAIL and NTPC and all the things like where they'll be getting our product gas will be supplied to the further processing and all. They'll be going to various kinds of utilities, and then downstream you will be finding it refineries. So they'll be producing your petrol, diesel, and different types of product. They'll be making LPG and all. That is the concept of this upstream, downstream, and we are from ONGC, and that is your upstream. That solely deals with the oil and gas production, exploration, and exploitation. So you can say call it as production. So I am going to talk about E&P business of ONGC, basically keeping in mind of ONGC, oil and gas exploration and production. When I was talking about ONGC, this is an upstream industry where we will be finding all kinds of activities of oil and gas. Recently, we started doing some kind of refining and other things also. Several things are there. This is a company profile you can read, and ONGC is producing at least 80% of your production is going on with ONGC, and recently we have gone into several kinds of renewable energy developments, and we are going good, and we are the largest producer, and we would like to be largest producer in the coming years also in renewable energy sector also. And we have taken several kinds of initiatives to upkeep the production levels. So now let us start doing our journey. As I said in the beginning, that we'll start first how oil is formed, then we will be going to exploration, and then development, and then drilling, and then ultimately production, and then what are the other challenges that we talk. So when we start talking about hydrocarbon, everybody knows, because you are all well aware that this is made of carbon and hydrogen molecules only. Larger molecules, very longer chains. And today crude oil left your this thing that you will be finding that crude oil, it is really crude. Nobody knows what is there in that except some 20-30 products, like nobody knows what are the crude oil contents even now. So this is made of hydrogen and carbon, and it is synthesized, naturally synthesized. So the origin of hydrocarbons, we call it as oil and gas, we call it as hydrocarbons. They are made of plant planktons or animal planktons. So they are debris, basically debris of pteridophytes, like certain kinds of plant materials, and then animal products. And then they are all over a period of time, millions of years ago, when they were cooked properly, and then they were Cooked in the sense that they were all submerged actually, just they are in the shallow oceans, and then ultimately they will be settling as sediments, and those sediments will become a thick shale like black shale. So that is called as at seabed. They will be made as black shale. It contains 5% of organic matter, and this is called as a black shale. The interesting thing about this oil and gas thing, it is not cooked for 1 or 2 years like. In 150 million years ago, the conditions were just right to make such kind of synthesis, I should say, artificial or natural synthesis actually automatically. Then these black shales are formed, piled up over a period of time, means it is 150 million years ago. That is Mesozoic times, in geological terms it is called as ancient era. So the world's main oil deposits are formed in shallow seas where plankton bloom and but waters are deoxygenated. Normally offshore is the main thing. Offshore means seabed is the main thing. 60 to 70% of oil is produced in offshore. So as you go down deep and deep, then what will happen is that this black shale, it will be transforming into several kinds of products. See, what it does is that this organic matter is first changed to, with increasing temperature, around some room temperature and all, it will be going to 50 to 60 degrees centigrade. It is in the kerosene form, and then it will be going to transform into 90 degrees centigrade. As it is feeling the temperature of 90 degrees centigrade, it will be going to oil. That is called as crude oil. Then ultimately, when it is heated up further, heated means automatically when it is receiving the temperature, then 150 degrees centigrade, like it will be turning into gas. That is called as natural gas. So what it does is that having formed oil and gas in a particular place, naturally because it has to move, because it has mobility, lot of mobility, oil and gas, they are very low, depending on their viscosity and fugacity, it will be moving through the porous rocks. So that is what is shown in this slide. So when it will be migrating upwards, naturally gas has a tendency to diffuse. So wherever porous surface is there, it will be going more and more. Oil and gas will be less dense than water. Along with water only they will be cooked, and all the three things will be existing in a particular rock. So beneath the surface. So that is called as a reservoir. That is what we call it as reservoir. Reservoir rock you call it as. This oil, when once it is going through different types of rocks, it will be naturally, because it has some outlet, no? That is called as permeable rocks actually. So like sandstone, some say shale and all kinds of things, limestone and all, it will be moving through the porous rocks, and then finally it will be settling somewhere in the hard rock where it is impermeable. So that is what is shown in the next left side of the thing. That there will be some kind of unevenness. No, it will be making some humps and bumps and all like thing like. So there will be oil, gas will be trapped like that. So that reservoir oil traps will be there. So then this reservoir rock will be in the down below left corner. You will be finding that there will be some patches. So naturally, because that will be settling in some places and some that will be unevenly distributed. So our thrust is to find out where it is to extract more and how much it is there. So when we start telling that when oil, gas and all the things, kerosene to black shale to kerosene to different types of product depending on the availability of different types of temperatures existing in the subsurface. So they will be trapped in different types of rocks. That is called as a source rock where the pools are existing. That source rock may be sandstone. Normally, largely it is sandstone, and it will be containing salt water and all. See, normally you know it, no? When one third is only earth, two thirds is sea. So naturally, the water that is present in the subsurface will be mostly seawater only, seawater like actually. So it may be diluted with different types of stuff like. So how to extract that? I know that I have migrated. I know that it is not in my hands. It is produced somewhere. It is migrated somewhere. It is capped somewhere in an impermeable rock. And now my struggle is to how to extract it. So different types of campaigns will be go, exploratory campaigns. First is that geologist will be finding out different types of sources with different types of clues. He will be studying the rock characteristics, and he will be knowing which kind of rock is the one which is, whether it is sandstone or limestone or this thing, whether it has capability to hold oil or not. All the initial studies are done by geological survey. That is called a geological survey. And then it will be going to geophysical survey. So geophysical survey, next slide I will be showing it. Either it is done in onshore or offshore. Offshore means mid sea. It is not on the shore. So where you will be finding all kinds of stuff. The geophysical survey, they will be doing how to find out where the oil and gas pools will be existing in this kind of situation, where the exactly things are there. Then I'll be doing drilling. So these activities, entire activities will be taking for drilling a well. It will be taking at least some 6 years. You can say that in terms of years. So by the time it comes to drilling, it is fifth or sixth year like that. So initial 4 years it will be taking these geophysical geological surveys, re-establishing the things and then quantifying the figures, how much is there and all. This is the same thing. What I was talking about, the seismic survey. It is called as the seismic survey, where different types of mapping and all this artificial intelligence figures and all. Next corner to left corner, you'll be finding this kind of thing, and this will be giving some kind of contours. And from the contours, you will be designating in the right down slide, right side of the slide down below, you will be finding it there is some kind of hump. That kind of things will be that is called as an anticline structure. So there you will be pinpointing out from the seismic survey. Then you will start going for oil exploration. Then this is the area where I want to drill and out. So this is the exploratory campaign seismic survey. Different types of vessels will be used, and they will be detonating some kind of explosions. Will be there. There will be that explosive will be there on land or offshore also. There are called as geophones actually, and that geophone will be recording what is the sound wave and all. Based on the sound wave, it will be telling that where the oil and gas pools will be existing. Then once it is pinpointed, then I will be drilling. Okay, this is my point. Right side of my slide, it will be indicating drill here. They will be indicating this is the area where I have to drill. So exploration and production, then I go for drilling. I know that this is the pool where that pool means this is the where oil and gas prognosticated estimations will be taking place. So I'll be telling that this is the area where it is my interest. So I'll be drilling a well. This is a typical offshore rig where you'll be finding it. The cost of drilling, you can as well understand, it will become very costly. So 30% of the well cost will be for your drilling only. So each well in onshore, at least shallow wells means up to 1,000 meters, it will be taking at least 1 to 2 crores like. So you can as well imagine the kind of steel and all kinds of things which are used. If five wells are drilled, some 3 wells are producing oil and gas, then it will be economical. Fortunately, we got very good success rate in ONGC. That's how we are surviving in Mumbai and all. So exploration production campaign, when self flow, when once oil and gas well is drilled, it will be flowing on its own. And when once oil and gas are produced for a long time, they will be up to 20 to 30% only you can recover by self flow. After some time, it will be self flow will be ceasing. Then you will be using some kind of artificial lift systems like oil sucking the thing, sucker rod pumps we call it as. Otherwise, sometimes we will be using steam injection, carbon dioxide injection, water injection like that to pressurize the reservoir and then produce again. It will be any additional recovery of 40 to 50% will be there. When once we come to exploration and production scenario globally, you will be say that the where sediments are existing, where I can produce oil and alcohol, those are called as basins. We have some 13 basins in India, different types of basins. Major basins like Krishna Godavari basin and your Mahanadi basin. Like that, actually, several kinds of the basins are there. Bombay reservoir, all the things are like that. Like that, 43,000 oil and gas fields are there all over the world. 575 are sedimentary basins. 360 are non-productive. 215 are only productive. So you can as well see the business actually. In spite of 575 sedimentary basins are there, only 215 productive basins are there. Like that, in our case also the same thing. We are around producing around 80% of India's the production levels now in ONGC. So this is 90% of oil and gas comes from 10% of these basins. That's what I was explaining. So this is the strategy. So world over, actually, more than 2 centuries, this oil and gas business has started. Even then, Antarctica and Arctic regions are unexplored. These are the regions still there to be explored. Like that is what is indicated. All over world, it is completely there in all kinds of things. And certain areas it is more, and certain areas are like less. You can as well imagine by now why it is certain areas are rich and certain areas are less. Actually, as I said in the beginning itself, the way it is formed and trapped and then ultimately it is producing, then naturally it will be somewhere it is rich and somewhere it is less. So then I know that oil and gas is I have identified the oil and gas pools or reservoirs or like that, where I can produce, I can drill the wells, and I can comfortably develop the area where I can produce large quantities of oil and gas. So the next step is how to produce. Obviously, any kind of process, when we start talking about it, it has to meet its end user. Why I am producing it? I have to sell it to my refinery. So sell how refinery, how whether sell refinery accepts my crude oil or gas. So what are my requirements, midstream and downstream requirements? So there will be some quality requirements. So I had to see that when I am transporting the products also, there should not be any corrosion issues, scaling issues. Scaling means calcium carbonate, calcium sulfate, or some kind of mixed scales, all kinds of things, even microbiological menace. These things, safety and environment concerns. When see, you can see that from Mumbai High to Uran, it will be around 205 kilometers pipeline is laid out, subsea pipeline. So when I see that, I had to see all these aspects before treating the oil and gas producing fields actually. So treatment philosophy will be whether it is techno-economically feasible or not, whether I can produce whatever I am producing it. It is not that I am producing it in platinum and gold like actually. So it should be producible and then it should be ultimately saleable like. So then quality monitoring also, around the clock quality monitoring, some kind of thing. That is why just investments are more in this kind of thing. Only public sectors like giants only will be using this kind of business like, not like it is not everybody's cup of tea. So this is a simple schematic like. So what we do is that these wells, different types of, I said that we will be drilling some kind of wells, some cluster of wells you'll be seeing it, and they'll be separated. Oil, gas and water are separated in some high pressure separators or low pressure separators. Gas will be compressed and distributed, dehydrated, and then oil will be treated. Treated in the sense that you will be removing the basic sediments and water. Then the water cannot be thrown out as you please. So it has to meet environmental norms and it is disposed. This is a schematic of this thing. So, what is the philosophy of this entire oil and gas process? Is simple logic. It is a physico-chemical treatment. Like it is not a very complicated thing. Like, but it appears simple, but it is very complicated because of the nature of the products. Actually, oil, because you do not know what is. It is not a simple product. Like it is a mixture of some several hundreds of products, and it is a three-phase phenomena. Oil, gas, and water will be there. So some emulsions and all things will be there in that. So you will be doing by gravity separations. That is the best thing. That's what we do it. Then when I start talking about this kind of thing under certain kinds of flow and temperatures and pressures, like how to separate it in an economical way. That is my main concern in the process. You see that the separator is the heart of the entire oil and gas process. I should say that this is you will be using this in engineering actually. You will be doing an horizontal separator or a vertical separator depending on the type of fluids and type of gas that is existing. There are different types of concepts that are there, design criteria, flow conditions, several other things are there. And then spherical separators are also there. Largely these spherical separators are used for LPG and all, where vapor pressure is more and large gas and where minimum liquid is there. That is kind of things like LPG and all are mainly used for NGL and all. And then vertical separators where there is low gas pressures and all things are there. See, normally most of the places will be using your three-phase separators because that is economical, cost effective. This initial stages, even in Ankleshwar field and all, we used to use these vertical separators. So vertical separators, that is easy to clean and several properties are there. Why and how these things are used is when the flow comes, the separations are said that large gas space is required in this kind of vertical separators and all, large separator diameter, several advantages are there and several disadvantages are also there. You can go through those disadvantages, but then the largely we are using mostly nowadays this horizontal separators only. The fluid you can see in the right side of my slide, you will be finding that the liquid will be separating in the middle of the thing, that blue shade that is given, that containing some kind of droplets like oil droplets, and it will be giving some kind of that oil will be there will be some interface, there will be some control valve which will fix, and when once it reaches some certain level, then automatically it will be going back to it will be going to the, it will be flushed out, I should say that. In the niche जो bottom में just then that will be your water, that is because of gravity separation. I said that top will be gas, so mist separator and several things are there. So how this oil, gas and water, they will be separated in the next slide. I will be telling about. This is a design of the separator. Normally when you find that different types of production separators are there, production separator you call it a test separator, you call it a test separator. It is a wellhead. You want to know that what is the flow and whether oil and gas, water and all, how much is my flow rate, whether it is economically to produce or not. Production separator means in the process centralized platform where several wells are connected and it will be producing oil, gas and water and further going to pipeline and all. That is called as several kinds of in offshore. It is called as process platform like BHN, BHS, like that. In onshore, you call it as CTF, central tank platform. This is only just we have to see. Obviously, my objective is to separate more and more rich products actually. So high pressure gas and high intermediate pressure gas, middle pressure or mid pressure or intermediate pressure gas and low pressure gas. Like that, actually 3 stages it will be separated in a single stage, just like solvent extraction. You cannot do in a single stage. So you have to recover more and more useful products. Like high pressure gas will be the ultimate thing that will be rich with the methane only. It will be lighter components. And low pressure gas will be just you cannot compress or anything like nowadays you have some facilities. It is normally flared like earlier it used to be flared. Mid pressure gas is the one rich with products which are useful for your LPG and all things like. So oil and water, then when I'm talking that you don't get pure oil, you don't get pure gas, you don't get pure water like. So I said in the beginning itself. So physicochemical separations, that chemical component when I'm talking about, where it plays a major role is that you water and oil are immiscible. Of course, that is there physically. But then when you are cooking at very high temperatures and high pressures, they form tough emulsions depending on the type of oil that you have. So it is very difficult to separate them under normal conditions. So you have to add some kind of demulsifying agents and certain kinds of things like they have some natural products which are like minerals and all things are existing. They will be making tough emulsion. That emulsion needs to be broken into oil and gas. That's what my treatment philosophy. See, normally when we start talking about this kind of treatments, then only single treatment or single type of process will not be working. So what we do is that I want to remove water. Water is a non-combustible material and it is no value for me. But then how much water can I remove? That is my strategy to be done. And treatment of free water is that free water will be knocked out as I showed in the separators in continuous process. And then I apply some heat, some 80 degrees or 60 to say 80 degrees like depending on the type of emulsion. And then I'll be adding some kind of chemicals, surface active agents like demulsifier, I call it as interfacial tension reduction will be there. And then some little bit of electrical voltage I will be applying, some 10 millivolts DC voltage will be applied. All the three together will be applied in that three-phase separator, and that will be resulting in the best water separation. That globules which are shown in that blue tinge, in the separator, that all the globules will be settling down, and then ultimately with some minimum separations that water will be separated. And this water, when once it is separated out, it will be going through several stages. Once again, oil will be recovered, and then pure oil. Pure means less than 0.1%. 1% oil and gas. Oil will be taken out, and that will be ultimately taken into further process for settling and all. It is only settling only. Just you will be breaking the emulsion in the separators. So Just let me tell you briefly about crude oil. So, having said about different types of oil, gas, and water process actually, then what is crude oil, what is gas, what is water? Then we'll be finishing the entire story, because then you will be appreciating the type of thing like. You can see that crude oil, as I told in the beginning itself, that crude oil is very complex mixture actually. One barrel means around American barrel, it's around 158 to 160 liters like. So that barrel contains several useful products. Till now, we have separated some of these things like in the gasoline, and you will be separating your fuel oil. These are all heavier cuts, jet fuel, and petroleum and petrol and all, diesel, all the things, aviation fuels and all. So this is the composition of your gasoline or your fuel. Carbon is 80 to 90%, hydrogen 10%, and all remaining things are like that. That is just hydrogen to carbon to hydrogen ratio is very high. That's how this is very heavy. When the carbon to hydrogen ratio is less, then it will be lighter oil or even lighter gas. Like ultimately, methane will be 1 to 4 like. So normally this entire oil trading is done by based on API gravity. So API means you cannot see it is density only, but one cannot say that density will be the factor. So you cannot remember the density. So that is this formula is there, and different types of oil you will be seeing the colors, and these colors will be telling you about all kinds of things like what kind of light oil or condensate will be very light, and the rich oil will be dark. So this is the different types of oil characterization components. Actually, you can say density, gravity, salt content. All the things are measured in the thing like it is an ocean lake. You can go through the Google or any kind of things like. So these are different types of properties of this thing. In this small correction is there. Pour point of Bombay High crude oil is around 27. It is not 21. It is treated thing like. So all the things are, it is comparable with world over crudes like it is lighter oil. So that is what I wanted to tell. I am rushing because these slides are available with you. You can as well go through that thing like. So what we do is that because when once you see that there is sour oils and sweet oils like. Sweet oil means 0.1% sulfur content will be there in that, and more than 0.1% is sour oil. So far you have been producing sweet oils, that is good, and you are all over world. Now you will be going more and more towards sour oils. So refining and all will be difficult. Let me tell you about gas processing. What is natural gas? I said that natural gas contains several kinds of mixtures. It contains C1, C2, C3, methane, ethane, propane, butane, and all kinds of things. Earlier, initially, we were not bothered about all these separations and all. Only just we are flaring everything and we are giving it to power generation like. But nowadays, we are extracting everything. That is the reason I am telling that it is rich with 70 to 90% methane, but remaining all 10% is value-added products like C2, C3 and all, ethane, methane, and all the things are separated by ONGC now, and that is what is marketed by even gas also, GAIL also. So natural gas treatment naturally, because once again the treatment philosophy is that how to remove your hydrogen sulfide, CO2, and then water. So that is why just you will be adding some kind of you don't add any kind of other treatments and all, settling only, but molecular seals and dry molecular seals, and then this will be passed through some amine solvents and all, so that H2S and all will be removed, and this water will be completely dehydrated with some molecular seals or even TEG, triethylene glycol and all. 7 pounds of water in 1 million standard cubic feet, that is the requirement for the transportation in the pipeline. So different types of stages which are involved in the things also, how to remove different types of products. You can go through that. Because of time constraint, I am not deep in doing much in this thing. You can virtually, I said in the beginning, the previous slide, you can remove several products in this. So that's how this is the kind of things like how to remove contaminants, how to make use of gas in a better way for value additions. So this is the treatment phenomena. Already I said that about absorption and adsorption and all the things are there. So some minimum heat is applied, some 40 to 50 degrees centigrade is there already to prevent hydrate formation. You will be adding some kind of thermodynamic inhibitors like glycol or methanol like that. during transportations. So gas hydrates is a major challenge. Not in our case, but many of the world over, actually, where the temperatures are very less. So the last but not least about this particular thing is produced water. In produced water, see, I said that oil, gas, and water, when they are produced, then water is an unwanted element. But then this water contains lot of oil and all, and it contains non-soluble oil and organic matters like phenolics and all, and dissolved solids, and all kinds of corrosion products, or even natural clay minerals and all things like. And all these products need to be removed, and even sometimes they will be containing geological material, they will be containing norm, they call it as naturally occurring radioactive materials and all. So you cannot simply dispose of them as you please. So you have to make some kind of regulatory norm. Some 40 ppm is the oil content that is to be disposed of in the offshore. So in onshore it is 10 ppm, remaining all to be contained in different types of trace elements. You will be finding this is the typical. I said that this is more or less salinities will be very high, and salinity is the major thing, and then remaining all are your calcium, magnesium, and all. That's why just the scaling tendency is more for this produced water. So you have to see that this entire water, when you are treating and all, there should be some proper precautions need to be taken for disposal also, because everything will be choked. So latest developments, when I start talking about, I know that the survival and fitness is that is the best thing for even ONGC also. When I am not able to produce more and more, then I have to go for unconventional sources of energy. Like, so this unconventional source of energy means shale gas, and then gas hydrates, less that white patches like you are finding in the globe, ice like, that is gas hydrates. You have very good rich resource of gas reserves in gas hydrates, that is exploration work is going on. And then coal bed methane, that is then Jeria and Raniganj and all these areas also, we are already doing some kind of work in that, either microbiological production and all. These things are going on all over world, and even ONGC has started for the past 10 years or so. It has been going on vigorously, and it is giving very good results now. You can see that Alberta tar sands, actually, so it is producing. You can see that we don't have that kind of quantities, but then these tar sands in Alberta, they are producing very huge quantities of oil and gas. Half of the world's proven oil reserves are existing in Canada's tar sands. That is what I am telling, that even 20, 30 years also, you have a lot of resources for this thing. But then they are confined to certain areas only, not for this thing. So that is why they are not as self-flow like. They are called as unconventional oil deposits, even shale oil, shale gas, all the things. You have to make a struggle for producing those things, and it's very costly. So the technologies are also developing very rich. Actually, the like artificial intelligence and augmented reality. Because earlier we were drilling the well and then finding out what is the now you can visualize everything. Virtual reservoir can be seen at the desktop, and then from the computer you can find out actually what is going on, and then the pinpointing the source and then the problems also. Then it is done, and that is just efficiency of operations with the digitalization and all has improved a lot, and ONGC is also introduced all kinds of things like that. Is just cost of operations also goes, but simultaneously you have a lot of recovery is improving nowadays. So this is what advanced visualization like, it will nothing tell. So this is one concept which has been introduced in the mid 90s by horizontal. Earlier we used to have a straight hole. This horizontal well will be, one well will be able to sweep lot of area nearby, and then you will be producing more and more. Phenomenal production has come up in ONGC history in mid 90s, when production levels were going on with horizontal drilling technique. So this is one concept actually which was done, and it yielded very good results in this thing. So this is what, with all the things, like as I said earlier, that ONGC has gone into several kinds of initiatives like underground coal gasification, gas hydrates, coal vision. Recently, I am working in ONGC Energy Center. We have started green hydrogen development technologies like hydrogen and all. So we are providing energy to whatever that is best possible from ONGC side that is struggling, and then we are doing from upstream. We want to maintain our strategy. So this is a GGS, where group gathering station. One of our colleagues is working there. So that is how that this entire thing, safety operations and all precautions are taken with all the safety equipment and all. In spite of the best thing, then there will be some kind of problem. But even then, that way just safety is given a lot of thrust in the ONGC operations, not only ONGC upstream operations. So this is the end of my talk. So these are the references, you can go through that. I thank you all for wonderful thing. I'm extremely sorry for rushing, but I don't know. I have been able to cover all the things, whatever I wanted to tell. The main thing is that to summarize, you will be producing oil and gas not like simple product. It is a complicated mixture. Three-phase separations are required, and three-phase fluids will be existing even during the transportation also. So that is just because of salinity and all. There is corrosion issues, microbiological issues, scaling issues. So a lot of maintenance and all will be there. But even then, per barrel of oil costs a lot. You can recently see the petroleum price and all. It has gone to 120 dollars per barrel. So that is just, it is a very rich boon. So with the improved minds, ignited minds like you people, and with different types of recovery rates and all, things might be improving in the coming years. This is all about it. Thank you all.
It's just amazing that Dr. Parvatalu could cover such a broad area in remarkably short time. If it had been me, I would have taken probably 2.5 hours, to make the presentation. But that just shows his level of comfort and his ability to explain things and understand which is important to explain and which can be skipped. I think we still left about 5 to 7 minutes. If any of you would like to ask any questions.
Youngsters, so you can ask any question or any kind of thing. Even I will also learn.
Ria, you can conduct the question answer session. Maybe you can start by asking a question yourself. Actually, this is a very bright class, because I've been teaching them. So but they get a bit shy sometimes, So I hope that they will ask something.
Sir, Dr. Parvatalu mentioned that the oil resources and basically the non-renewable resources are currently sufficient to fulfill our needs for the next 2 decades. But according to the current growth of renewable energy sources in India, after 2 decades, would we be in a position to completely fulfill the absence of these oil resources by means of resources like solar energy, hydro energy, etc.?
No, that is a wonderful question actually. But then see, the thing is that despite the best efforts actually, that renewable sources will not be complete solution even in near future also. By 2050 and all, only 30% or even at most you can say that with all innovations, some 50% only renewable contribution. And remaining all has to be met by the traditional oil and gas business only, because oil and gas will not be extinct actually even by 2000. Initially they thought it will be extinct by 2040, but it is not going to be happening like that. So still this existing will be there, but then India already it is 80% you are importing. So our struggle is that 80%, that is a very too costly business, for as far as country is concerned. So if you can contribute your requirement, if you can enhance the contribution of your renewables to at least 50%, say around 40% is import substituted, then the cost of the import also will be going more and more. As I said, in the coming years, refining and all will be very costly. So see, at $100 per barrel itself, you are not able to cope with your own economy. Like that, actually, renewable will not be able to give you complete solutions because of their own limitations. But even then, there is a chance, actually, like hydrogen mediated economy and all things like. But then 100% conversions are not possible in the coming by 2050
There's
also.
another question from Hardik. Hardik, would you like to ask?
Yes, sir. So I wanted to ask about the recent reforms the government has got. So the government has increased the addition of ethanol from 5% to 10%. So how does it affect the amount of fuel which is going to be imported by India, and will it help us to last for a longer period of time, like more than 2050?
See, as I said, some when Ria was asking this question, the thing is that contribution of methanol or ethanol or any kind of thing, all kinds of alternatives are planned. And I said that remember today you are importing 80%. If you can reduce the content by little bit also, the cost will be reduced drastically. So when you have very good kind of rich resources like methanol, or even sugar industry is able to produce some ethanol, at least there are, it is a dual purpose actually. The methanol or ethanol introductions and all. One is that you have some commitments to Paris Accord and all by 2050 net zero commitments are there by India also. It is a Paris, it is a signatory to decarbonization drive. So you will be little bit impressing the world that you are decarbonizing. Simultaneously, you are meeting your own energy needs also. You cannot stop your energy needs, no. So you have to do that thing. So it will not be giving a significant actually impact. Actually, you cannot say that, but it will be beginning actually.
Okay.
To
Can
diversify your thing.
Dr. Parvatalu, there's another question by Rishabh Chauhan.
Thank you, sir.
Sir, in the drilling process, sir, how do we decide how far should the steam injector be from the reservoir?
No, that is what I said. Thank you. At least you asked one question actually which is pertinent to my talk. So what I wanted to tell you that initially that geological and geophysical repeated surveys when they have taken, that seismic survey when I said that it will be giving the contours up to some 3 kilometers, 4, 5 kilometers down below the surface, what are the different types of strata that is existing. And then where this oil and gas anticline and all I was showing, where there is likelihood that this oil pool exists like. So when I know that this is the area at some 1500 meters or 2000 meters or 4000 meters where this pool exists, then to that extent I had to go on drilling it. And then I had to see that ultimately to exploit the oil. Is it clear?
Yes,
Yeah,
sir.
I think we have time is up now. So if you can conclude.
Thank you, sir, for gracing us with those remarkable words of insight. It was an amazing session, truly. And we hope to have future interactions with you. And thank you once again, and have a great day ahead, sir.
Thank you. Thank you.
Dr. Parvatalu focused on the upstream processes where you are recovering oil and natural gas from the fields. I come to the last part of the course, which is related to petrochemical refinery. The refinery is where they make a wide variety of chemicals, starting from that crude oil and natural gas. That's what they are doing. Now, although we say refinery, refineries are not homogeneous. There's not one type of refinery. Like in our country now, with all the huge population and the trucks and the cars and everything, we need a large amount of fuel to run our vehicles. So if your emphasis is on fuel, then you'll have to see how to tailor your refinery so that you're maximizing fuel, petrol, diesel, CNG. CNG, of course, is usually would be done by more upstream, but the other things, okay, have to be actually done in the refinery. There could be another refinery where coke is a very important material from the refinery. When I'm talking about coke, I'm talking about pet coke, petroleum coke, or it could be a refinery which has lubricant as a large focus area. You know that lubricants, how vitally important for running all these machines. So lubricants play a massive role. And finally, it's petrochemicals, all the variety of molecules which we require. Acetic acid, ethylene, these are all petrochemicals, and they have got to be synthesized starting from that crude oil or natural gas. What I'll do is that I'll try and introduce you to the downstream. Now, it is such a complex operation that I cannot do anything but only scratch on the surface. I will also send you a NPTEL lecture on the refinery where you'll get more details of these processes. Let me also tell you that the area of petrochemicals is becoming increasingly more vulnerable because fossil fuels, as you heard, will last for another 30 years, 40 years. What are we going to do after that? And so the huge opportunity for chemical engineers will be to use a different type of feedstock like bioresources, but use it in the refinery and to see how you can marry the two. So that would be a great area to work on. Many times, the crude oil which you will get out will have an emulsion, and you need to break that emulsion. The people in the upstream may not be doing a perfect job of it. So one of the most important operations in a refinery is really crude oil desalting. And in the process, what do you have to do? You have to remove the water and you have to remove the salt, not just the water. You remove the salt, which means that you need to break up that emulsion, and then you may have to add some emulsion breakers, which are some chemicals do that job, and sometimes they have to be done at a high temperature, the desalting. And since many of your volatiles, your crude oil might have relatively volatile fractions, so you may have to actually carry out the desalting operation under pressure at those high temperatures. You may succeed in breaking up this emulsion. And I can tell you that one of the ICT students, Arjun Shah, about 3 years back, he had done an internship in Reliance. He was telling me that in the Reliance plant, this crude oil desalter is the rate limiting step. Everything is controlled by that. Because if you cannot do that, you cannot go forward with the rest of the process. And so that is that important. This whole refinery business also requires heat. You require temperature. So many of the processes have to be carried out at high temperature. So what one does normally is that one takes some of the crude oil and puts it in a furnace where you generate heat. Even though one does separation and remove some of these gaseous things, but they will always be dissolved in your crude oil some volatiles. Because there are certain safety regulations, you may want to get rid of the very volatile stuff before it goes into the furnace. So some of the very volatiles actually you remove, and then a part of the oil you feed into a furnace, and in the furnace is just basically generating heat, water and CO2. And the bulk of the oil, after you have removed some of these volatiles, that goes into what is known as the crude distillation unit. And these distillation unit, the crude distillation unit, is an ambient pressure process. But adjacent to the main distillation unit, there are multiple other distillation units. They can be of all kinds. They can include even pressure distillation unit, vacuum distillation unit. Like when we talked about separating nitrogen and oxygen, you are actually doing a pressure distillation when we were applying that, you remembered 5 bar pressure. So likewise, many of these things also you can do a pressure distillation. Okay. And typically this is how your crude distillation unit looks like. Okay?
So I had a small doubt, sir.
Yeah.
So what's the job of a crude distillation unit you mentioned?
Yeah. So the crude distillation unit will basically fractionate the crude into some broad fractions. You understood? Which will depend on their boiling point. So for example, if let's say I have volatilized off the very highly volatile stuff, which we did, then the next most volatile thing are these naphthas. So what am I doing? I'm taking my my crude over here. I'm applying steam. So I'm heating it up. The whole thing is getting heated up. The most volatile fraction will of course travel to the top, and I'm collecting it as a naphtha fraction. Naphthas are typically cycloalkanes, those kinds of molecules, not very high boiling, fairly low boiling. So I take out the naphthas from here. Then what happens is that we have always been used to, like, even when you have done some work in the laboratory, and we when we do distillation, we usually take out or distillate from only a single port, isn't it? In the top you have a condenser, and at the end of the condenser you have a outlet from which you collect things. But that's not the way in which you do distillation in the crude distillation unit. You will have side arms. So you are simultaneously collecting four streams from the crude distillation unit. And increasingly, as you go from the top to the bottom, the boiling points are higher and higher. And that's why, this is not going to volatilize all the way to the top, but it will volatilize to some extent. So I'll collect a fraction here. And you will see from the name, HGO means heavy gas oil. LGO means light gas oil. So it is going to be more volatile than the heavy gas oil. Now, when we are distilling, you are covering a temperature range of up to 340 degrees centigrade. You understand? This is not a heating to just 100 degrees centigrade. You are heating to high temperatures, and then you are collecting these fractions. Now, from the crude distillation unit, you will get the broad fractions. As I told you, light ends, light gas oil, heavy gas oil, but they themselves will contain many constituents. So what then you do is that these are then connected to now a fractionating columns. So this is where you will be doing fractional distillation. Each of these will again get separated into multiple products, all of this. So you will end up getting several streams, from a crude oil. Later on, what they'll do is they'll do further chemistry on these isolated streams. And in some cases, what they'll do is that they will blend various streams. Blending is a very important operation in a refinery. And there are some things which will simply not boil over. They will just remain here. They will be extremely non-volatile. And those are your atmospheric residues. Now, these atmospheric residues, one is, of course, they will have extremely high boiling things, so it's not boiling at all. And what happens is that, a crude oil is not just oil, it's not just hydrocarbon. Many times the crude oil will contain heavy metals, like some of the heavy metals I'm showing you: vanadium, nickel, iron, calcium. Calcium is, of course, not a heavy metal, but these kinds of things will be present. And so as I'm removing much of the stuff, these are getting more and more concentrated, this stuff. Now, these are the fractions from which you will make things like asphaltene for road. You'll make bitumen. You'll make coke, petroleum coke, which will go into steel production operations. So all of that stuff you'll produce. From this, the heavy gas oil, you may produce things like lubricants, which are also fairly high molecular weight compounds. You might produce industrial heating oils, that kind of very heavy oils. There is something known as low sulfur heavy stock, which is used as a fuel in industries. That kind of stuff you might get over here. Then from here, from the light gas oil, I might actually recover things like diesel, home heating oil, things like that. Okay, and the more light fractions, I might get jet fuel, kerosene, with a typical chain length of maybe about C12, C14, C10, that kind of things I'll get here. And the naphthas, which will be typically around C6 to C8, those kinds of compounds I'll get over here. So that's what you'll end up getting. Now, let me go through a few terminologies.
So I had one doubt, sir.
Yeah.
So you mentioned that blending of various streams is important.
Yeah.
So So what does blending involve? Like blending of the HGO product, the LGO product, those streams, or
Yeah, once you get the finer streams from each of these streams, you might have applications where none of the streams individually are able to give you the desired property. But when I mix them up, blend them in a certain proportion, I might be able to get it. You understood? So
yes, sir.
I will be able to match the kind of properties which are required for specific applications. And obviously that will require knowledge of the downstream applications. And usually the people who practice those applications, they will tell you which fractions to mix with what. Is that clear?
Yes, thank you, sir.
Now, that day, Dr. Parvatalu told you, about the API gravity. API means the American Petroleum Institute gravity scale, and it is 141.5 divided by the specific gravity minus 131.5. Obviously, what it means is that when my specific gravity is low, then naturally my API gravity will be high. That plays a huge role in controlling the price of my crude. Usually, the higher is my API gravity, the more the fuel will command, the more price. And so people will want to know what is the API gravity. But then there is another factor which is known as the Watson characterization factor. The two together are sometimes used to determine the value of your crude oil. Now, what is this? Basically, what it is a volume average boiling point. So what is the volume average boiling point? So let's say I'm taking a crude oil. I find out the temperature at which 10% of my total weight came off as volatile. For each of these, I'll record a temperature, boiling point. Then I take the average temperature. So I take the average of the five, and that then is the average temperature. VABP is volume average boiling point. So I might take that kind of a boiling point, and then it is raised to the power 1/3 divided by the specific gravity. And that is known as the Watson characterization factor. Obviously, based on a vast experience, they have been able to derive these equations and find that these are quite useful in judging the kind of petroleum crude that you have. The other is extremely important is the viscosity. But you don't use the dynamic viscosity. What you do is you just use the plain kinematic viscosity, which is the resistive flow under gravity. So you just take a capillary tube, you put in your crude, and you see under gravity what is the rate at which the crude is falling. So that is your kinematic viscosity, and that effectively is dynamic viscosity divided by the density. So that is got the units of centimeter squared per second. That is the one that is typically used by petrochemicals refineries. Remember, petrochemicals are the source of fire. So there is a need to understand basic definition of flammability before you do anything else. And so I thought I will introduce you to these. Many of you might already be familiar with the terms. If you do, it will just be a revision for you. Now, the two very important terms in terms of flammability of a gas, one is the lower flammability limit. So, for example, if I've got too little of flammable gas in the atmosphere, it won't catch fire. Even if you light a matchstick, it won't. In fact, I remember sometimes I used to go to the petrol pump to fill petrol, and barely 50 feet from there, I see one guy doing welding job. They're constructing something, and I was thinking, what would happen if the whole thing catches fire? No, presumably these people have taken the precaution, and they know that it is below the lower flammability limit, the atmosphere around the place where the welding activity is going on. So then it won't catch fire. The second is that if you have got too much fuel, remember that you need both fuel and oxidizer, which is oxygen, for combustion. So if, for example, I only have fuel, I don't have any oxygen, then obviously it's too rich, it won't burn. It might sound strange to you. You can even put a matchstick, inside. Don't try it. If it is absolutely full of, let's say, fuel, but it shouldn't catch fire because there's no oxygen. We all use this term, flash point. When I'm increasing the temperature of a liquid, the vapor pressure will increase. Now, when the concentration of the vapors is equal to my concentration in the lower flammability limit, that is the flash point of that particular fuel. Flash point, remember, is a temperature. The temperature at which you reach the LFL value. Flash point is just that, it's a flash. So if I strike a match, it will flash for a second, not even for a second, maybe millisecond, and it will die out. Why? Because I don't have sufficient concentration of my fuel. It cannot be sustained. But if, for example, let's say I ignite and I find that the fire is burning for 5 seconds, then that point is known as the fire point. So obviously the vapor pressure will be much more at the fire point, and it must be able to sustain burning for 5 seconds. Finally, there is another term which is auto ignition temperature. It is not igniting because I introduced a ignition. I did not introduce a spark. It just auto ignited because of its high temperature. It's also known as the kindling point.
So I had a doubt, sir.
Yeah.
So in the case of UFL that we are talking about, sir.
Yeah.
So in the slide it was written that beyond the UFL the gas becomes too rich.
Yeah.
So what does that exactly mean? Like what will
It
happen
means that
beyond
I
the?
have insufficient oxygen.
Okay.
This finally is what a refinery looks like. Whatever I told you, that if you take all this, this operation, vacuum distillation, then each of these will, there'll be a fractional distillation. This is all the separation part. After that, there will be downstream. We'll be doing organic reactions like alkylation and things like that. You'll be doing hydro desulfurization, hydro denitrification to remove sulfur nitrogen. Then I'll be getting my purer fractions, and then I'll be again blending things. So there are wide variety of different operations which are going on. Altogether, if I remove that desalting and flashing, the initial, I told you how to remove the water and the salt, and also to get rid of the very volatile stuff. So if I take out those 2 unit operations and start from the process where I'm putting it into the crude distillation unit, altogether there are 22 units. Let us now see what are those 22 units. Well, you have seen the crude distillation unit. If you have got things which are, I think I can pull them out with the vacuum, then I'll do a vacuum distillation. If I want to make more petrol and diesel lighter fractions, then I have to crack my heavier molecules. That's called thermal cracking. Cracking can also be a catalytic cracking. And these are vitally important in a petrochemical refinery. Then I've got my hydrotreaters. So I've got, let's say these could be compounds like thiophene, which is present in my crude oil. I need to remove it. How do I remove it? I do a hydro desulfurization and I produce H2S. And remember, all the sulfur for sulfuric acid comes from this hydrotreating units. And for all hydrotreating means I have to actually apply hydrogen. So a refinery needs a lot of hydrogen. Then I've got separators. Separators is I've got solid, liquid, and gas. I have to separate them out. And the splitters. Splitters are where I have a liquid fraction and then I'm splitting it by distillation into lighter fraction, heavier fractions. Reforming, as I told you, it could be that I'm doing isomerization. That's reforming. I may do alkylation. I may need alkylated products. So I may do alkylation. And then when I did hydrotreating to remove my H2S, NH3, etc., those have got to be treated. You cannot just let them out. So that is gas treating, which I have to do. And then I've got my blending pools where I blend various fractions just to get the right desired property for specific applications. Only in the case of the naphtha splitter, the naphtha splitter actually is a true splitter in the sense that I'm actually doing a distillation, fractional distillation. But they also have other splitters, like a kerosene splitter. What this splitter means is that I'm not doing anything. I'm just deciding, if I've got, say, 10 tons, how much kerosene I need for one application, how much kerosene I need for another, how much for a third, and I'm just splitting it by weight, that so much is going for this, so much is going for that. So that is meant by this stream splitters. They're just splitting it into different streams, but I'm not doing any separation. Only the naphtha splitter does a separation. Now you can have a very interesting situation where out of those 22 units, which look so complicated, I can broadly classify them in 4 blocks. One is called the separation block. The separation block is really, if I look at this part, it's all separation block. What am I doing? I'm all doing separation. Okay, firstly, I have to do a pre-flash, as we talked about, to get rid of the volatiles. I've got my crude distillation unit. I've got my vacuum distillation unit. I've got my naphtha splitter. And I might also have, for the very volatiles, I have to have C4, C3, C2 separation. So I need separators. But all of those are basically separations. So this is all separation block. Then I've got the treating block. Treating block would be the desalting unit, as we discussed, because I have to treat, I have to remove the salts, or I have to remove sulfur if there's thiophene, if I've got some pyrrole fractions or some amines, pyridine, I have to remove those. So that's all part of hydrotreating, and I have to do that with hydrogen. And what will I end up with? I'll end up with things like H2S, ammonia, etc., which then I have to take care of. Then I've got a reactive transformation block. This is where I'm doing chemistry. Chemistry means I'm doing cracking. It could be thermal cracking or it could be catalytic cracking. So I'm doing a cracking, breaking up larger molecules into smaller molecules. I may be alkylating. I may be isomerizing and reforming. Reforming is quite the same as isomerization, not so different. But this reforming is like, for example, if I say I want to convert methane into syngas, that's also reforming. And then I've got a 4th block, which is just things like blending operation, kerosene splitting, just splitting it into ratio and proportion, butane splitter, again doing much the same thing. So these are all physical operations which you are doing. So out of the 22 operations, I can break it up into and classify them very neatly into these 4. Then you need experts for each of these units, and broadly again for the broad separation, etc. So you'll have super specialists, then some who are specialists in the broad area of separation. So the kind of specialization that you do in your chemical engineering, you might find that you will be especially useful for one part of the operations as compared to another, and people might get trained accordingly. Is it all clear to everyone?
Yes, sir.
Understood the process well?
Yes, sir.
Okay, I'm so happy.